Okay, so we'll start the next lesson. I got my calculator open yet? No. Okay. Right. So in this lesson now, we're going to have a look at something called surds. So what exactly are those? These are a type of number. They're numbers of this form: a plus b root c. And just so you know, this is called root, or more precisely, square root. So this whole thing together is called a surd. So let's look at the different things we can do and have to do with these. Okay, so the first thing we'll want to know how to do is how to simplify. So my first example then, simplify. Let's say simplify root 108. So there's different ways to do it, but the way I like to show people what to do is to use something that they learned probably in elementary school actually, but you might not have known its name. Prime factorization, prime factor. So I'll go to the side and explain what to do. No, actually, I think I'll scroll down here. So what you do is you think of any two numbers that multiply to make 108. Doesn't have to be any two numbers that multiply to make 108, except of course 1 and 108. So we could go with 2. Simple example: 2 and 54. Now we cannot continue with 2. Because the only things that make 2 are 1 and 2, so we have to stop with 2. 54 we can continue, we can just go 2, okay, no, let's do 6, 9. 6, 9, as an example. It doesn't matter, 6, 9. We can actually continue with both. 6 is 2 and 3, yeah. And we have to stop here and here. And the 9 is 3 and 3. So what you have now is 108 equals 2 times 3 times 3 times 3. Oops, no. 2 times 2 times 3 times 3 times 3. I like to pair them. So 2 and 2 is 2 squared. Yeah, 3 and 3 is 3 squared, and this 3 by itself is just a 3. Yeah. Now, root 108 is root this, and root this. So 2 squared with a root is just 2. This is just a 2, and
3.
This is just a 3. So together this is a 6. And nothing happens here. So the answer is 6 root 3. Now, you can check this on your calculator, I think. So, in the exam, of course, you can't do this. But in the exam, you can do this to check the answer. And it is. Okay. Okay, I'll just give you one to try. Example. Try this one. Root 245. In the exam, you get marks for showing your steps. Okay. So if a question in the exam said to simplify and you just wrote this, you won't get the full marks. Now you don't have to show all of this, because there's other ways to do it. This is just one way to do it. Okay, try this one now. So let's see. Well, because of the 5 here, I can see a 5 goes into it.
49.
49 then. Well, that's actually good. So yeah, 7 and 7 then. So 7 root 5 would be the answer then, yeah. Because this would be root 7 squared root 5. So root 49 is 7 root 5 then. So 7 root 5 is the answer here. Okay. Scroll down now. So let's make it a tiny bit harder. So root 624 plus root 39. So at the moment we can't add these together. There's no clear way to add them together. We'll have to simplify each one separately. So let's have a look at each one separately. 624 3 goes into that. 208. Yes. 4 goes into this, doesn't it? 52. Oh, we're not finished with 4. 4 is 2 and 2. Okay, 52, 13 and 4. Right? 13 and 4. Yeah, and 4 is 2 and 2. So this is root 2 squared, root 2 squared, root 3 and root 13. Okay, and 39 is just 3 and 13. So is root 3 and root 13 root 39. So there's nothing to simplify here. This will be 2, well, I suppose put it together, 4 and root 39 plus the other root 39, which is one of them. So that's it simplified. Now I do wonder if the calculator can do this. Let's see what happens. Root 624 plus root 39. Okay, so we know that the answer is right here. Okay, write this one down and we'll have a look at another example. So the key idea in this example is before you can simplify, you have to simplify each part. Okay, let's do a couple more examples here. Can I scroll down? Yep. Okay. 2 root 105 minus 3 plus root 105. Nothing too interesting here. This is like what we saw in the last lesson, except there's only one term here. This multiplies this one, and this multiplies this one. So 2 times 3 is 6, so it will be minus 6 root 105. And then here, the second one will be plus 2, and root 105, root 105. So what do these two make? Just 105 then, yeah. Which is 210. And I'm just going to finish it by writing it the other way. So the answer is 210 minus 6 root 105. This is more usual way of writing it. Okay. So let's look at another one like this, but a bit harder. Oh, and let's see again what happens with the calculator. 2 root 105. And then root 105. No. Can't do this one. Now, I wonder if it's because the 105 is a bit too big. Let me just change this to something smaller, like, I don't know, 15. Yeah, so it just got a little too big. Actually, I'm not quite finished because I haven't actually checked if the root 105 can be simplified, I just realised. So let's just check that if it can. 105 is 5 and 21. That's finished. That's a 3 and... Yeah, so it can't be simplified, yeah. So this is the answer then. Okay. Can I scroll down? Yeah. So next one now, we'll do this one. 7 minus 2 root 5, 6 minus 6 root 5. Okay, so 7 multiplied 6, that's a 42. 7 multiply this one is a 42 root 5. This one multiply this one is a 12 root 5. And lastly, this one multiply this one is plus 12 times 5. Okay, so that's a 60, yeah. 42 minus 54 root 5 plus 60. So that is 104 minus 54 root 5. And clearly, this, 102, of course it is. 102. Okay, and clearly the 5 is already simplified. Okay, so we'll do another example. So far we've done many examples of multiplying, but we haven't done an example yet of dividing, which is actually the hardest one to do. Okay, I'll scroll down. Yeah. Okay, so here's our example. Minus 10 plus root 147 over minus 2 plus root 3. Now, what I want to check first before I do anything is that 147. Can I do anything with the 147? So let me just see. 147 is 3 and 49, isn't it? Yeah. 49 is of course 7 by 7. So root 147 is 7 root 3. Okay, so we'll change that first. Minus 10 plus 7 root 3. Okay. Now, I'm sure somebody knows the next step here.
Rationalize.
Yeah, which means what exactly?
Times it by root 3 plus 2.
No, the other, no, close. You made a tiny mistake.
Minus 2. Oh, yeah.
If the sign changes on the root, so it's minus 2 minus root 3. Very good. So, rationalizing the denominator, meaning you multiply here to simplify. You multiply the top and bottom by this. Minus 2 minus root 3 and minus 2 minus root 3. Because really, you're still multiplying by just 1, which just doesn't change the value. But this multiplication actually makes it easier. And there's a name here for this. So minus 2 minus root 3 is the flank of minus 2 plus root 3. Does anyone know what this is called compared to this? Minus root 2 minus root 3 is the something of minus 2 plus root 3. Anyone know this? Anyone? Yeah, you think you do? Go on, try.
I know the notion, but I don't know the name of English.
Does anyone know the name? No? Okay. Conjugate. Please write this word down since you didn't have it. Huh? Yeah, conjugate just means you take your surd and you change the sign on the root. So if it was a plus here, it's a minus here, and vice versa. Yeah, I'll scroll down a bit. Conjugate. Okay, so let's... Yeah, question? No? Okay. So, actually before continuing, let's just practice a couple of these. So, if I had 2 plus 3 root 5, then the conjugate is 2 minus 3 root 5. If I had 3 root 5 plus 2, the conjugate is
3 root 5 minus this, yeah.
no.
No? Minus 3 5.
Yeah, it's still the same, 2 minus 3 root 5, because it's only the sign on the root that changes.
Only the sign.
On the root.
Yeah.
Yeah. Okay. 2. Yes, correct. And 3 root 5.
Negative 3 root 5.
Okay. Yes. Yeah. I can scroll back.
Yeah.
So this is the surd, and this is its conjugate. Okay, back to the question. Now let's multiply. So on the top we have 4 multiplications. Minus 10 multiply minus 2 is 20, and then minus 10 multiply the next one is plus 10 root 3. And then 7 root 3 multiply minus 2 is minus 14 root 3, yep. And 7 root 3 multiply minus 3 will be minus 21 then in total. And then on the bottom, minus 2 by minus 2 is a 4. Minus 2 by minus root 3 is plus 2 root 3. Plus root 3 multiply minus 2. Minus 2 root 3. And finally, root 3 by minus root 3 is minus 3. Huh? Yeah. So, something interesting happens here, you noticed. Yeah. Yeah. This must happen. The reason we use the conjugate is to make this happen. So this must happen. If it didn't happen for you, what does that mean? There's a mistake in the question, or there's a mistake with you? Yes, mistake with you. So just be careful, make sure that these cancel then. So on the top we have minus 1 minus 4 root 3, and on the bottom 1 then. And we don't always get 1, okay? This part was an accident. Here it's 1, but you know, it can be any number, 4 or whatever. So what would happen is, if you didn't get 1, you must then finish by splitting it into 2 and put each one over this number. In this case it's 1, so it's easy. Minus 1 over 1 is minus 1, and 4 over 1 is 4 then. And this is the answer. Let's see what the calculator says. Minus 10 plus root 147 minus 2 plus root 3. Yes. So we can see that's right. Yeah.
I was wondering about calculation of your lesson. It doesn't appear on the module. I tried to get.
Oh yeah, it's on the YouTube channel.
So
I can show you on your phone in a little bit where to find them, yeah. Okay. There's a special type of this one I want to show you. I'll just scroll down if I can. I don't know, we'll just say 1 plus, I don't know, root 2 over root 5. So you should multiply the top and the bottom by the conjugate. What's the conjugate here? Minus root 5. But in this case, you don't really need the minus, because if you took out the minus, you still have the same result. You're trying to remove the surd from here. And you can see that even with a plus, it's still gone, because root 5 by root 5 is 5. But we'll leave the minus in just to see what happens. So on the top, I'll have minus root 5 minus root 10. And on the bottom here, I'll have minus 5. So this will be minus 1 over minus 5 root 5 minus, and I think I'll change this back actually to root 5 root 2. No, that doesn't help me any. I'll keep it as root 10 over minus 5. So that is 1/5 root 5 plus 1/5 root 10 here. So really, I kind of have like 2 surds here at the end, because I have 2 roots. So if you want your answers almost like this, 0 plus 1/5 root 5 plus 0 plus 1/5 root 10. It's like I have 2 at the end. This doesn't usually happen in the exam. What I'm trying to say is, in the exam, they usually make the question so that you always end up with this at the end. Okay? But, you know, it doesn't always happen. That's what I'm trying to tell you. Sometimes you can simplify it only down to 2 roots, not 1 root. So it's not wrong if you get this in the exam, but maybe you made a mistake, because usually in the exam they try to make it become just 1. Okay, so just remember that. It's not wrong if you get it, but just double check, because they don't usually do this in the exam then. Okay? Right, so what we'll do, before you can try these, I'll just let you take a little break, and then when you come back, we'll practice some of these, and we'll have a little bit of time left, so we can at least start the next lesson, although I don't know if we'll finish it. Let me see it. We'll start it anyways. We'll see how we do. So you can take a break for 10 minutes now if you like. Can I close this?
Yes.
Yeah.
If in this case, in the exam,
Yeah.
what should I do the answer?
If you've got something like this?
Yes.
Nothing. That's it.
That's it.
That's it, yeah. I can close this?
Yeah.
Yeah, I'll show you now. I can close this.